Okay, we have an alternating series, and with this one we can tell just by the divergence test that if we take the limit as n approaches infinity of the entire thing, which is what the divergence test is, we take the limit as n approaches infinity of this, then this is going to be alternating. It's never going to settle, so the limit doesn't exist, so it diverges. We can already tell, but we are in the section about alternating series. So let's practice alternating series. With alternating series test, you want to, first of all, you have to meet two conditions. But the first one is that b sub n plus 1 is less than or equal to b sub n. Your second condition is that the limit as n approaches infinity of b sub n is equal to 0. So with our first condition, we could plug in n plus 1 wherever we have an n for b sub n. B sub n is just the part without the alternating. So we would have e to the 2 over n plus 1. Is that less than or equal to e with 2 over n as an exponent? So yes, this would be less than or equal to that because we would have a larger denominator. So it would pass our first part of this test, but then we would have to take the limit as n approaches infinity, the limit as n approaches infinity of b sub n, which is e to the power of 2 over n, e to the power of 2 over n. And so then we would have to plug in infinity into here. That would give us our exponent going to 0, which would give us 1. Which would give us 1, and 1 is not 0. So that means that our test would be inconclusive. Our test would be inconclusive because we didn't pass the test. If we pass both tests, we would say it converges. But since we didn't pass both tests, it's inconclusive. So we would have to go and do our divergence test anyway. And so our divergence test, which we can readily tell, is when we take the limit as n approaches infinity of the entire thing. It's not like the alternating series test where you just take the limit as n approaches infinity of this region and hope it goes to 0 so you can prove convergence. No, with this one, you take the entire thing. So that's the divergence test. That's just what you learned before. And this one can tell you if it diverges. That's why it's called the divergence test. So if we plug in infinity, we would get 1 over here, and we would get negative 1 to the n minus 1. So this would be 1, right? So we can not even write it. And right here, we would have an oscillation. We would be causing an oscillation because we would have odd terms, even terms, odd terms, even terms. So we would never settle on negative 1 or 1. Which one is it? You would never settle. So it's constantly alternating. Therefore, the limit as n approaches infinity does not exist. Therefore, it diverges.